Cold storms swept across grasslands that stretched all the way to the horizon. To the south, red dust from young deserts was constantly lifted by the winds into towering walls. On the ground, massive creatures with bulging muscles dominated everything from African jungles to the frozen plains of Europe. And in a small corner of the African continent, a strange primate had just appeared. Not yet a predator, nor a ruler, but their existence would soon change everything on this planet. This is not a scene from a science fiction movie, but truly what Earth looked like 300,000 years ago. At that time, Earth was in the middle of a Pleistocene glacial cycle, a period when climate shifts were powerful enough to shape the entire evolution of life. Gigantic ice sheets from the poles expanded century after century, lowering sea levels by dozens of meters compared to today. Regions that we know now were once connected by vast land bridges, leaving traces of ancient migration routes of animals and humans. In Africa, where the climate was more stable than in the rest of the world, stretches of rainforest and savanna formed something like a primordial model of a complete ecosystem. However, even this so-called cradle of life was not spared from the effects of the glacial period. Long droughts alternated with wet phases, causing the landscape to shift constantly. Rivers swelled during rainy seasons and shrank in dry seasons, creating natural migration corridors for large mammals. Moving northward, Europe was an entirely different world. Not the lush land we know today, but endless cold steppes stretching thousands of kilometers. Deciduous forests shrank into small patches, giving way to frigid grasslands, an unforgiving environment, yet one rich with food for giant animals like mammoths and woolly rhinoceroses. Winter temperatures could drop so low that the weakest individuals in a herd might die, forcing the animals to move constantly to survive. Asia, meanwhile, was a far more complex mixture. Dry steppes merged into eastern woodlands, and farther south lay dense tropical forests. This diverse terrain created countless shelters, hunting grounds, and breeding areas for animals ranging from saber-toothed elephants to long-toothed tigers and vast herds of grazing mammals stretching hundreds of kilometers. This region was also an essential part of the migration routes of large animals, and later would become the path our ancestors had to follow to leave Africa. Between the three continents, the Middle East acted as a biological bridge. Its climate was often harsh, but stable enough to become a crossroads for numerous animal populations. According to archaeological evidence, this area was also one of the earliest routes used by ancient humans to move out of Africa. A perilous journey that eventually opened the way for global expansion. Everywhere on Earth 300,000 years ago, landscapes were changing endlessly. And this complex climate geological mosaic created the perfect stage for the most powerful creatures of the era to emerge. Earth during this time was not only a world of extreme climate shifts, but also the golden age of giant animals. Constantly changing environments produced many distinct ecosystems, each ruled by its own dominant species. From Africa's scorching savannas, the sparse forests of the Middle East, to Europe's frozen plains and the vast lands of Asia, everywhere teemed with life, yet everywhere held countless dangers. 300,000 years ago, Africa was the most life-rich continent on the planet, and in fact, extensive fossil and archaeological evidence confirms that it preserved one of the most intact megafaunal diversities from the Pleistocene all the way to the present day. However, at that time, the ecosystem was far richer and far more ferocious than it is today. Along the grasslands and savannas stretching to the horizon, vast herds of giant herbivores created a spectacle that now survives only in scattered wildlife reserves. African elephants of that era included multiple ancient subspecies, some of which were often larger than modern elephants, with long tusks extending outward like curved blades. Geographic distance and environmental conditions made them significantly different from modern elephants, even though they still belonged to the family Elephantidae. Not far to the south, rivers that swelled during each rainy season became the territory of ancient hippos, primitive buffalo, and large herds of antelopes. Several species of antelope and zebras from that time no longer exist today, but fossils show they were once widespread and served as a major food source for top predators. Among those predators, the giant African hyena was one of the most remarkable creatures. According to fossil research, it was larger than today's spotted hyena and possessed extremely powerful jaws, capable of crushing the bones of large prey. They were not merely scavengers, as many assume. Bone markings indicate they were active hunters capable of taking down prey equal to or even larger than lions. Sharing the land with them were ancient big cats. African lions of the time were significantly larger than their modern form. Although not quite as massive as the European cave lion, they were still a serious threat to any solitary creature. Ancient cheetahs and leopards were also present, appearing similar to their modern relatives, but possibly possessing certain adaptations for drier climates. This was an ecosystem so diverse that any species entering it, whether herbivore or carnivore, had to struggle every single day to survive. And it was precisely in this place that Homo sapiens formed and adapted under pressure from the planet's most formidable predators. In complete contrast to Africa, Europe during this era was a cold, dry, and extremely challenging land. Thick ice sheets in the north expanded constantly, creating a harsh climate that allowed only a few types of ecosystems to exist. On the frigid steppes, often called the Mammoth Steppe, giant animals became icons of the entire period. The woolly mammoth was the most characteristic species. With thick fur, heavy layers of subcutaneous fat, and tusks that could curve more than 4 meters on the largest individuals, mammoths were proof of extraordinarily effective adaptation to freezing environments. Living alongside them was the woolly rhinoceros, a powerful herbivore. They carried large horns on their heads and a thick coat similar to that of mammoths. Though not as aggressive as modern rhinos, they were still considered difficult to approach and could attack fiercely when threatened. Based on studies of their body structure and behavioral models of modern rhino species. But the true rulers of Pleistocene Europe were the large carnivores. The European cave lion, about 20 to 25% larger than modern lions according to bone analyses, was one of the most successful predators of the Ice Age. Ancient cave paintings in Chauvet depict them without manes, possibly an adaptation to colder climates, although this remains speculation based on artwork with no soft tissue evidence. Also present in Europe were the giant cave bear, weighing nearly a ton in the largest individuals, along with ancient wolves and cave hyenas. These species formed a complex competitive network in which each had to fight for limited food resources in a harsh environment. Despite its severity, Europe produced powerful biological pressures that deeply influenced the evolution of human species such as Neanderthals. Asia, 300,000 years ago, was the meeting point of the greatest variety of climates and environments on Earth. Landscapes ranging from the dense rainforests of Southeast Asia, the Siberian steppes, to the high mountains of the Himalayas created diverse conditions for countless animal species. To the east, Dense forests and open woodlands were home to ancient tigers, which may have been as large as, or even larger than, modern tigers, depending on the subspecies. Some populations possessed larger canine teeth, considered traces of certain long-toothed tiger lineages, though this remains debated among paleontologists and has no final conclusion. Moving northwest leads to the world of the megafauna, the giant deer whose antlers could span up to 3 meters. Adult males carrying antlers weighing tens of kilograms were proof of strong sexual selection within the species. One of the most remarkable mammals of Asia at the time was Stegodon, an ancient relative of elephants. They possessed long, straight tusks and massive bodies, but lived mainly in forests or tropical lowlands. Based on genetic analysis and fossil evidence, Stegodon lived across regions from Southeast Asia to China and is believed to have been a strategic food source for large predators. Herds of ancient bison, primitive wild horses, and early camels also migrated across the vast steppe. These were primary prey for predators such as ancient wolves and ancestral cheetahs. With its rich ecological range, Asia became a crossroads for many animal species and for many human species, creating a diverse genetic reservoir that still leaves traces in modern DNA. The Middle East during this period was one of the most biologically important regions on the planet. Although the climate was generally drier and hotter than Africa's, the area experienced long wet phases that produced vegetated valleys, lakes, and grassy plains. Vital oases of life. Because of its position between Africa, Asia, and Europe, the Middle East became a meeting ground for many large animal populations. Ancient horses, wild cattle, gazelles, and various large cats migrated through the area seasonally. This was also where earlier human species such as Homo erectus once lived, leaving behind tool sites and archaeological traces. According to archaeological studies, this region would later become one of the earliest gateways through which Homo sapiens left Africa. But around 300,000 years ago, it was still primarily a land of wildlife and other archaic humans, creating a complex, competitive landscape among species. All of these ecosystems formed a vibrant yet tension-filled picture. Every species, large or small, had to continually adapt to climate shifts and predatory pressure. And in that harsh world, the young primate species was slowly learning how to survive. While giant animals still ruled the land, a quiet but decisive event in evolutionary history was unfolding in Africa, the emergence of early Homo sapiens. There was no opening ceremony, no clear moment of origin. Only small changes in body structure, in cognitive ability, and in the way a group of primates adapted to the danger surrounding them. Yet those accumulated changes laid the foundation for modern humans. According to archaeological and genetic research, the earliest Homo sapiens appeared in Africa around 300,000 years ago. Fossils found at Jebel Irhoud in Morocco are among the most important evidence, showing that their skulls and body structures already possessed many modern traits, though some features, such as skull shape, were still different. Morphologically, early Homo sapiens stood about 1.60 to 1.70 meters tall, with strong builds, well-developed muscles, and high endurance. Their faces had more prominent cheekbones and lower foreheads compared to modern humans. However, their brain volume was comparable to ours. Around 1,300 to 1,450 cubic centimeters, indicating that complex cognitive abilities had begun to emerge. A pivotal transformation was the structure of the skull. Although still elongated toward the back, it had begun developing the rounded shape that allowed larger growth in brain regions associated with abstract thinking and language. Although it is not yet possible to determine whether they possessed a fully developed language, many scientists believe they already had a communication system far more complex than that of earlier human species. This assessment is based on comparative models involving brain size, laryngeal structure, inferred from the hyoid bone, and the level of social organization recorded through archaeology. These changes did not occur overnight. They were the result of hundreds of thousands of years of adaptation to an environment filled with pressure from predators, climate shifts, and cyclical resource scarcity during the ice ages. Contrary to the common image of wild, primitive humans, Homo sapiens, 300,000 years ago, possessed a far more advanced level of social organization. Archaeological evidence and comparative ethnography allow partial reconstruction of their lifestyle. Homo sapiens of this period almost certainly lived as full hunter-gatherers. They moved seasonally, following the shifting availability of food sources. Levallois stone tools, a complex knapping technique that produced sharp flakes, are clear evidence of highly developed tool-making skills. These Levallois blades could be hafted onto wooden shafts to create simple spears or knives. They were effective for butchering, skinning, and especially useful when hunting large animals. Coordinated hunting is considered one of the greatest advantages of Homo sapiens. This conclusion is drawn from tool placement, animal bone traces, and processing patterns found at ancient occupation sites. Although many earlier human species had learned to use fire, Homo sapiens were among the groups that used it more consistently and strategically. Archaeological evidence shows that they used fire to cook food to increase energy absorption, stay warm during cold nights, repel predators, burn grass to clear paths, or attract herbivores to new patches of young vegetation. The ability to control fire not only improved living conditions, but also allowed them to expand into colder regions. Groups of this period typically lived in small bands of around 20 to 40 individuals. Their social structure was likely flexible, with task sharing based on sex and age. Children were cared for collectively, while adults took turns hunting, gathering, and defending the group. Archaeological evidence from campsite layouts shows clear divisions between tool-making areas, cooking zones, and places for processing animal carcasses. This organization reflects planning ability and coordination, traits that contributed significantly to the success of Homo sapiens. There is considerable debate over whether Homo sapiens of this era possessed fully developed language. Although there is no direct evidence, many scientists believe they had at least a complex communication system based on brain development, an inner ear structure similar to modern humans, complex social behavior, and tools requiring multi-person coordination. Therefore, the safest conclusion is that they possessed a proto-language, not fully modern, but sufficient for conveying ideas, strategies, and danger warnings. Homo sapiens were not the only human species on Earth 300,000 years ago. In fact, this was a period of high human diversity, with several species possessing superior strength, larger bodies, or better adaptation to temperate environments. Neanderthals were the characteristic human species of Europe and Western Asia. With robust bodies, thick bones, large rib cages, and powerful musculature, they were superbly adapted to glacial climates. Neanderthals had sophisticated stone tools and hunting abilities equal to those of Homo sapiens. Archaeological evidence shows they buried their dead and possibly decorated their bodies, indicating complex social awareness. Homo sapiens and Neanderthals had not yet encountered one another at the time of 300,000 years ago, but they would cross paths tens of thousands of years later. Unlike Neanderthals, Denisovans are known primarily through DNA and a small number of fossils from Siberia and Tibet. They were a human branch that split from a common ancestor with Neanderthals and were likely well adapted to high-altitude environments. Evidence from bones and teeth suggests that their bodies may have been quite large, though this remains an interpretation based on limited data. Homo heidelbergensis and several other archaic human branches may still have existed in certain regions at this time. However, their presence at the exact mark of 300,000 years ago varies by region and is not always clear, meaning precise identification depends heavily on ongoing research. What is certain is that Earth at this time was not as empty of humans as many people imagine. Instead, it resembled an evolutionary forest where multiple human branches coexisted, competed, and at times exchanged genes. Among all the human species alive then, Homo sapiens were not the strongest nor the most physically resilient. But what set them apart was flexibility. Flexibility in lifestyle, in diet, in movement strategies, and in social organization. Homo sapiens could live in a wider range of environments, from rainforest to savanna, from high mountains to coastal plains. This broad adaptive capacity was what allowed them to survive a series of severe climate fluctuations over the hundreds of thousands of years that followed. Yet despite these advantages, early Homo sapiens were still only a very small part of the world 300,000 years ago. Across the continents, enormous beasts and other archaic humans still ruled the land. To survive, our ancestors had to face dangers that are difficult for modern people even to imagine. And that is when the true struggle for survival began. Even with important advantages in cognition and coordination, Homo sapiens 300,000 years ago were still tiny creatures in a world full of giants and harsh environments. They did not possess sharp claws, extraordinary speed, or thick hides to withstand freezing climates like many large mammals. All they had was a developed brain and the ability to cooperate. But to survive on a violently shifting planet, that alone was not enough. They had to confront the apex predators of the age and the natural challenges that could wipe out entire communities after a single dry season or an unusually harsh winter. The first and most immediate danger came from large predators. On the African savanna, Homo sapiens groups always had to stay alert to the distant roars of ancient lions. The big cats of this period may have been larger than modern lions and often operated in pairs or small groups, making them a true threat to small human bands. Equally dangerous were the giant hyenas. Based on skull size and jaw force modeled from modern relatives, they were likely capable of crushing bone in a single bite. This made nighttime especially dangerous. When fires burned low, or when the group became careless, hyenas could approach and attack any weak individual who wandered too far from the group. In areas near forests or rivers, leopards, ancient cheetahs, and Nile crocodiles were daily threats. Crocodiles could strike within seconds, making simple tasks such as collecting water or catching fish extremely risky. As our ancestors expanded their range northward, they encountered a completely different kind of enemy. In Europe, blizzards, deep sub-zero temperatures, and the scarcity of food were enemies no less terrifying. In such an environment, encountering a European cave lion or a giant cave bear was the last thing anyone wanted. Cave bears, according to fossil evidence, were much larger than modern brown bears. A single strike from one could cause instant death. Ancient wolves and cave hyenas also appear in high density within fossil sites. showing that they were organized predators, competing directly with humans for food. A small group of Homo sapiens often had to avoid direct confrontation, choosing instead to hide or use the landscape to evade these animals. All these threats created an environment in which the smallest mistake could cost the group one or more individuals. And loss was dangerous, because human groups of this era were very small and depended closely on one another. Although physically weaker, Homo sapiens excelled in strategic thinking. This is demonstrated through the analysis of hunting sites, butchery marks, and the distribution of tools within ancient camps. One of the strongest weapons of Homo sapiens was the ability to imagine outcomes before acting. They could observe the movement patterns of herbivores, detect weaknesses within the herd, and choose proper ambush locations. Evidence from ancient hunting grounds shows that humans drove prey into dangerous terrain, used natural traps like cliffs or swamps, and split into groups to force prey in predetermined directions. These techniques required tight coordination and trust among group members, qualities rare in animals but common in humans. Levallois tools are clear proof of their technological sophistication. Their production required preparing a stone core beforehand, from which sharp flakes could then be struck. This shows an ability for long-term planning, something earlier human species had only begun to develop. Fire also allowed them to expand their habitable range, cook food for greater energy intake, and most importantly, create a barrier against predators at night. A group with fire was a group with a far higher chance of survival. Humans of this time lived in small groups, but flexible social structures and clear task division made them more effective than most other animals. Indirect evidence, such as healed fractures on bones, shows they cared for one another, helping injured individuals recover. Something extremely rare among large animals of that era. The ability to share labor was also essential. When some members went hunting, others stayed behind to protect children or gather plant foods. Every individual played a crucial role, helping the group maintain long-term stability. No species can survive indefinitely by relying on a single region. This was especially true during the climate fluctuations of the Pleistocene. Heavy rainfall expanded forests, drought expanded savanna, and thousand-year warm-cold cycles made many regions uninhabitable for certain periods. Research shows that major climate fluctuations could have changed the vegetation structure across Africa. Extended dry periods caused the food resources of Homo sapiens to shrink. As rivers contracted and herds migrated farther away, human groups had to expand their foraging range. Chance opportunities, such as an unusually long rainy season that greened the Sinai Peninsula, may have created short windows that allowed them to cross the region. This is a hypothesis supported by many researchers based on pollen analysis, plant fossils, and paleoclimate data. There were two main migration routes. The first was through the Sinai Peninsula, connecting Africa to the Middle East. The second was across the Bab el-Mandeb Strait, when sea levels were lower, making the journey easier. These routes would later be used repeatedly by later waves of migration, but at 300,000 years ago, they were only the first and very risky steps. Once they moved beyond Africa, Homo sapiens began to enter the territory of other human species. In the Middle East and Western Asia, they may have encountered late Homo heidelbergensis or other archaic human populations. Genetic data shows that interbreeding between Homo sapiens and Neanderthals occurred around 50,000 to 60,000 years ago, long after this period. However, earlier encounters between the two species are still possible, even though no definitive evidence exists. Migration was not simply movement. It was a harsh test of the adaptability, creativity, and social organization of Homo sapiens. Each group that left was an evolutionary experiment. The groups that adapted survived, while those that failed vanished forever. Those hesitant early steps laid the foundation for the global expansion of humanity tens of thousands of years later. The era 300,000 years ago was a brutal stage of survival. Young humanity was only one among countless species struggling to live. But within this struggle, the most important abilities of Homo sapiens were sharpened: reasoning, cooperation, and adaptability. And as climatic changes continued to challenge the planet, those early humans began the long journey that would lead to our dominance today. 300,000 years ago, Earth was a place where harsh climates, giant animals, and multiple human species coexisted, creating a fiercely competitive evolutionary landscape. In this context, Homo sapiens was only a small branch, yet the only one flexible enough to withstand the tests of nature. Those first steps in such a harsh environment laid the groundwork for the path humanity would later follow. A journey far from finished, with countless stories still waiting to be uncovered.